So hi everyone. I'm very excited to introduce Valentin Hoffmann. Valentin Hoffmann is a postdoc at the Allen Institute for AI and the University of Washington. His work broadly focuses on the intersection of NLP, linguistics, and computational social science with specific interests in tokenization and socially aware language models. And previously, he was a PhD student at the University of Oxford and a research assistant at LMU Munich. During his PhD, he also spent time as a research intern at DeepMind and a visiting scholar at Stanford University. For the presentation, feel free to, raise your hand throughout or ask questions in chat. But I'll let you take it away, Valentin.
Thank you so much. Yeah, I'm super excited to be here. I should say I woke up with a slight cold this morning, so I hope there won't be any bigger inconveniences, and I hope that my voice will stay for the entire duration of this hour. Yeah, I'm very excited to be here. I want to talk today about some recent work we did on probing covert racism in language models via dialect prejudice. This is work which has just been published in Nature earlier this year, and so most of the talk will be about that. And then towards the end of the talk, I'm also going to quickly talk about some ongoing work that we are doing that extends the findings from this first paper. And yeah, at this point, I also want to give a huge shout out to my collaborators. Ria, Dan, and Charisse, with whom I worked on the first paper, and then Fangru, who's a PhD student at Oxford, who's the main driving force between this ongoing project that we are still doing. Yeah, and what Abel already said. So if there are any questions, please do interrupt me at any point or post them on the chat. All right. Okay, so there has been a lot of work and a lot of interest in racial bias in AI systems. Most notably, there has been work on racial bias in facial recognition systems. So there's this very famous case of Joy Buolamwini, who was a PhD student at the MIT Media Lab and was working on a project where she wanted to use facial recognition software. And it only worked for her when she was actually wearing a white face mask, which is quite a yeah, quite a clear instance of racial bias in AI technology. Another example, which has been prominently discussed also in the press, is racial bias in criminal risk assessment systems. So it is well known that automated systems for assessing criminal risk systematically assign higher risk scores to individuals with darker skins. And this is independent of the underlying risk profile. So again, a very clear instance of racial bias in AI technology. Now, we are interested in language models. So what about language models? What are the kinds of racial bias that we know exist in language models? And so to give you an idea of the work that has been done in the past, I want to briefly discuss two studies that in a way show how a lot of other studies also have approached this problem of racial bias in language models. So one study was actually done here at USC, which is already an older study, so 5 years old. And they looked at like GPT-2 style models, so non-adapted, non-post-trained. And the way how they approached the problem of racial bias is they prompted the language models with prompts such as the black man worked as, and then they looked at the generated continuations, at the continuations that were generated by the language model. And as you can see here, the example continuation for the prompt the black man worked as perpetuates racial stereotypes. And notice that race is explicitly mentioned to the language model here, right? There is this marker of the racial identity in the form of black man. A more recent study from last year, so exactly 1 year old, this is a study from Anthropic, where they look at the discrimination of language models against certain social groups and minorities. And they use a very similar methodology. So here's an example prompt that they use. So it starts with the defendant is an 8-year-old gender race unemployed auto mechanic who has been charged blah, 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 blah. And then in the end, it says, given these competing factors, should a judge grant the defendant bail? And I mean, you would insert fitting age, gender, and race value into these slots. So it would be something like the defendant is a 19-year-old female black unemployed auto mechanic or something like that. And then they would again analyze the discrimination in the decisions that language models make based on that. And again, I mean, notice that race, but also the other social variables are explicitly mentioned to the language model. It's very interesting when you look at their findings. They actually find positive racial discrimination. So anything above 0 here is indicating positive discrimination, meaning that the decisions that the language models made were more positive for Black people than for white people, which is, I think, quite surprising. But yeah, so they interpret this in their paper as evidence for actually positive racial discrimination. Um, Quite the opposite from what earlier studies had found. Now, this in a way raises this slightly odd question. Maybe given this finding from 2023, maybe racial bias has been resolved in language models, right? Oh, we see actually positive racial bias, so maybe there's no problem after all. And so the key motivation for our work and a key shortcoming, I think, of a lot of prior work is that it only focused on racial stereotypes and discrimination that were triggered by explicit mentions of race, right? Something like black man, a black auto mechanic. So the race is always explicitly mentioned to the model, and then these prior studies would analyze the continuations generated by the language models and see, okay, what are the stereotypes that are contained in these continuations. However, we know from a lot of work in social sciences that racism can manifest in way more subtle forms, way more covert forms, and these have been largely overlooked in prior work. And a very important term to mention here is this idea of colorblindness. So this idea that racist attitudes and racist behavior is overtly rejected. So people would say things like, I don't see color, I just see people. But this very statement allows racist behavior to continue to exist on a more covert, more subtle level. For example, via residential choices, legal outcomes, education. So, but in more covert forms. And in terms of this explicit racism, which is what prior work in NLP at least has focused on, this would be rejected. And one example of such covert forms of racism are raciolinguistic stereotypes, which are stereotypes due to raciolinguistic ideologies. So this idea that due to speaking in a certain way, people might be less intelligent, less educated, and so on. And one example of this is raciolinguistic discrimination against speakers of African American English, who experience discrimination in a range of contexts, including education, employment, and legal outcomes. And this has been widely documented in the literature. One very prominent example was the George Zimmerman trial, which was after George Zimmerman had shot Trayvon Martin, whom you can see in the middle here. And later in the case against George Zimmerman, a key witness was Rachel Jantel, who was a friend of Trayvon and had called him very shortly before Trayvon was shot, and she spoke heavy African American English in court, and her testimony was later dismissed due to being incomprehensible and not credible. And like, this is one example where speakers of African American English face real world disadvantages and discrimination due to their dialect. Now, I think for us as computer scientists, it's very important to realize that these raciolinguistic stereotypes, they are widely encoded on the web. So here's one example of somebody asking on Quora, how come most African Americans don't speak English correctly? So this is a clear example of a raciolinguistic stereotype. And our language models are trained on this data. And hence, I think it is a valid question to ask whether language models pick up raciolinguistic stereotypes from the training data, given that we know that models are very good these days to pick up any statistical correlations they can find in the data. So the key questions I want to pose in this talk are, A, do language models exhibit raciolinguistic stereotypes about speakers of African American English? Then 2, in what ways do these raciolinguistic stereotypes, if they exist in language models, affect the decisions that language models make about speakers of African American English? How can raciolinguistic stereotypes in language models be resolved? And then finally, and this is some ongoing work, can raciolinguistic stereotypes beyond these representational and allocational biases also affect the downstream performance of language models on certain tasks we are interested in. So this is the agenda for today. Are there any questions at this point? Okay, then I'll head into it. Okay, so do language models exhibit raciolinguistic stereotypes about speakers of African American English? The methodology that we used here to answer this question was that we looked into the sociolinguistic literature and we found this technique called matched guys technique, which is a way of probing the stereotypes that people have about dialects. And the way how this is done is the following. So participants listen to audio recordings in two languages, and then they are asked to make judgments about various traits of speakers. So here's an example of how such a survey or how the thing that participants would get in the matched guys technique looks like. So you see different traits like old-fashioned versus modern, stupid versus smart, and so on. People would listen to two audio recordings in two languages or two dialects, and then they would rate the speakers that they heard along these axes. Now the clue here is that actually the two recordings show the same speaker. So it's a bilingual speaker who just speaks in two guises or two languages. And so we know that any difference in the ratings that we observe here are actually due to differences in the dialect or differences in the language, and not so much, any other characteristics of the speaker, so such as voice quality or something like that, right? Any difference we observe here must be due to the dialect, given that the speaker is the same. But this is not told to the participants. Now, of course, we are not working with speech here, but we adapted this matched guys technique to probe raciolinguistic stereotypes in language models. And how we did this is the following. So we started with matched texts in standardized American English and African American English. So for example, the standardized American English text would be, I am so happy when I wake up from a bad dream because they feel too real. And then you can see the corresponding text in African American English in blue below. So these are matched in meaning. There's no underlying difference in the content. And so again, the idea would be, I mean, we don't have any voices here, but the idea would be that any difference in the behavior of the language model we observe must be due to dialect. Then we embed these texts in prompts that ask for certain speaker traits. So one prompt would be a person who says, then we insert the text is, and this is the same, of course, for standardized American English and African American English. And I should say we have various prompts. So we try to make sure that any results we observe here are not due to specific wordings or phrasings in the prompt. Then we take these texts embedded in the prompts and feed them into our language models. And then we look at the probabilities that the language models assign to different adjectives, such as brilliant, dirty, intelligent, lazy, and stupid. And then we compare the probability distribution over the adjectives in the standardized American English setting with the African American English setting to see whether there are any differences. Now, to make this a little bit more quantitative, so we computed association scores with African American English. And for that, we computed this probability, namely the probability of an adjective X following an African American English or standardized American English text T embedded in a prompt V and given a language model theta. And then based on this, so this is either for African American English or for standardized American English and only for like one specific text. But of course, we are not really interested in the associations for any one specific text, but for the general associations that the language models have with a dialect. And so what we do is we look at various African American English and standardized American English text pairs. And then for each of these text pairs, we compute the probability of a certain adjective X following the African American English version of the text, the probability of the adjective following the standardized American English version, and then we compute this, in a way, the log probability difference. And so this gives us a score which is specific to a certain adjective, a certain prompt, and a certain language model. Yes, I think there's a raised hand. Please go ahead.
Hi, yeah, I have a question. How did you come up with A, the pairs of like SAE and AAVE, and B, how did you come up with like the set of adjectives that you were testing
Oh,
for?
yeah. That is coming on the next slide. Great question.
Perfect.
Yeah. Just before I go to this slide, so just for interpretation, if this Q score, this association score, is positive, then this means that for a specific prompt, across all our African American English, standardized American English pairs, the adjective X is more strongly associated with African American English than with standardized American English, and vice versa. If the score is lower than 0, the adjective is more strongly associated with standardized American English across all of our text pairs than for African American English, still specific to a certain prompt. I mean, most of the time we average across our prompts, but I just wanted to make this clear. And now we are coming to this great question. So where do we get this data from? So we looked at two data sets here. One is a data set released in 2020 by Grunwald and colleagues. Here, the authors collected African American English tweets, and then they had speakers of African American English translate those tweets into standardized American English. So here the meaning is matched. This is the prime example of matched dice probing where there's no meaning difference. Now we know that there's a lot of other, properties and features of language that strongly correlate with dialect. So, for example, certain topics that are more likely to be discussed in certain dialects. Some certain the content might vary. Maybe some certain musicians are more likely to be discussed by speakers of African American English. Maybe books, or the content co-varies. We know this from a lot of work in NLP. Content co-varies with dialect. And so we were worried a little bit that by controlling for meaning and controlling for content, certain nuances of dialect prejudice might actually, fall out of our, like be neglected, be ignored by our analysis. So what we did is we included a second data set where the meaning was actually not matched. So we just had two sets of texts in African American English and in standardized American English. We took this from a heavily used data set of African American English tweets released by Blodgett and colleagues. And so we did do a lot of analysis to see, is the dialect prejudice amplified in the non-meaning matched setting? And it was overall pretty much like all the results were pretty much the same across experimental setups and so on. So what we did in the paper and what I'm also going to do here is I'm just going to present both settings together. But just, for you to know, we looked at both settings, and in a way, there would be the potential, right, that by also taking this content variation into account, the dialect prejudice is somehow bigger. But I mean, at least in our analysis, this didn't seem to be the case. So that's about the data. And then about the adjectives, that's also a great question. So we drew upon the adjectives from the Princeton Trilogy. That's a series of studies conducted between 1933 and, I mean, originally 1969, but people have continued doing this for the later decades that looked at stereotypes about different nationalities and ethnic groups, including African Americans, done in the United States. And how this worked was that the researchers here gave to participants a list of 84 adjectives. Some of them you can actually see here. So industrious, musical, efficient, and so on. And then in a way, participants were asked to pick the 5 adjectives that are most matching for certain, national groups. Here you can see the results for Germans, Irish, but they also have it for African Americans. And so we use these adjectives, so for one, I mean, we thought this is a good basis for our analysis, but then this also allowed us to compare the stereotypes that we observed for the language models with humans across a range of different decades. So we could, we had the comparison with humans, and then we also had the temporal aspect. We could compare across decades, which was quite beneficial for our analysis. So these are the adjectives that we look at. So like the setup is we have the prompts, a speaker who says text either African American English, standardized American English is, and then we look at the probability assigned to these adjectives from the Princeton Trilogy. Okay, now a little bit more details about how we actually did this. So we analyzed the covert raciolinguistic stereotypes, which are caused by dialect in our setup. And we also looked at the overt stereotypes that the language models show when they are actually explicitly asked for their attitudes about African Americans. And so notice the overt setting is very similar to these earlier studies that I showed you initially, where people, said the black man is working as, and then they look at the continuations. I mean, we do it a little bit more constrained here. We say a person who is black is, and then we look at the adjectives from the Princeton trilogy, right? So you see the setup is very similar. Just in one case, we use dialect as a racial marker. Race is never explicitly mentioned in the covert setting. And in the overt setting, we specifically have a marker of racial identity. And so in the covert setting, we compare African American English with standardized American English. In the overt setting, we compare black with white as adjectives in this setting. So that's the setup. And yeah, as I already mentioned, we compare the stereotypes of the language models in these two settings, overt and covert, with those of humans from the Princeton trilogy. And given that the Princeton trilogy already stopped in 1969, we also used one more recent reinstallment from like 12 years ago. And we looked in the study at 5 language models: Roberta, which is an encoder-only language model, then 3 models of the GPT family, 2, 3.5, and 4, and T5, which is an encoder-decoder language model. So we wanted to have, I mean, Roberta is already a little bit old school, but we wanted to, given that nobody had looked at this form of bias before, we also wanted to see, okay, how does it look differently for an encoder model? I mean, GPT-4 is a very recent model, GPT-2 not so much, so how does it change with time? Yeah, so we thought this covers, I mean, it's not a large number of language models, but we still thought it covers the space of possibility relatively well. Okay, so let's take, or are there any questions about the experimental setup? Otherwise, I'll go into the results.
I have a question. Did you vary, for example, punctuation or capitalization, other markers, like lexical markers that are not related to the words themselves?
Yeah, that's a great question. And so we did here for the meaning match texts, we just took the translations that the African American English speakers had generated for the study done by Grunwald and colleagues. We just took them without changing them any further. I should say, I mean, when you look at these texts, there is also, I mean, in general, the translators were instructed to really translate everything as closely as possible to the original, besides the dialect. So in general, it's a relatively faithful translation. And you do see, for example, that certain weird punctuations also show up in the, because it's from social media, they also show up in the translations. Later, I will report about a post hoc analysis that we ran where we more specifically looked at individual features and really trying to relate our findings back to specific properties of the African American English texts. We did not look at punctuation, though, I should say. Any other question about our setup? All right. Okay. So first of all, here are the results for humans. That's nothing we did. So you can see the 3 original Princeton trilogy studies and then this reinstallment from 2012. And I mean, you can see that these are the top 5 adjectives. So in a way, the top stereotypes about African Americans in these studies. We mark in red here negative, so adjectives negative in sentiment. We took this from a crowdsourced data set. And adjectives and positive adjectives here marked in green. So you can already see, I mean, the 2012 adjectives are slightly more positive than, for example, the 1933 adjectives. And this is also something that has been observed for the Princeton trilogy, that at least the reported stereotypes about African Americans have become more positive over time. Now, here are the covert language model adjectives. So here I show the adjectives that have the highest average association with African American English across our different prompts. And this Q score, as I showed earlier, is also across our text pairs. And so you can notice that the covert stereotypes of all language models, they are all negative in terms of the top stereotypes. They are all red, they are all negative. And as a result, I mean, these are all more negative than any of the top stereotypes that humans reported about African Americans in the Princeton trilogy. Now, for the overt stereotypes, the picture is different. So the overt stereotypes, first of all, they are much more positive than the covert stereotypes of the corresponding language model. And they are often also more positive than the human stereotypes about African Americans. So a couple of comparisons that I want to draw your attention to. So first of all, when you look at the 1933 stereotypes, you have stupid, ignorant, and lazy are three adjectives. And these three adjectives show up for GPT-2, Roberta, and T5, right? So three of the five adjectives, of the top five adjectives for these three language models are actually also showing up for the human stereotypes from 1933. So this is, we also computed how likely this is to happen based on chance. And I mean, this is highly significant that you have such a high match among these models and with the 1933 stereotypes. Like lazy, for example, lazy also shows up for GPT 3.5, and like ignorant also shows up for GPT 4, but this 3 out of 5 match, we only found it for these older language models. Another thing that is really interesting, when you look at GPT 3.5 and GPT 4, which are, by the way, the only post-trained models, so the only models that went through RLHF here, they have only positive stereotypes in the overt setting, something like brilliant, passionate, musical, imaginative, artistic, and they have only negative stereotypes in the covert setting. So yeah, quite a pronounced divergence in these two settings for these models. Now, we wanted to measure this a little bit more quantitatively. So what we did is we measured the average favorability of these top stereotypes based on human favorability ratings for these adjectives. And this is based on this crowdsourced data set that we also use to color the adjectives on the last slide. And so first of all, we noticed that the covert stereotypes, which you can see here in the bottom panel, they are more negative, also quantitatively, than any human stereotypes about African Americans ever experimentally recorded. So you can see that the dots here for all 5 language models, they are more towards the left than the red dot for 1933. So they are, in terms of sentiment, they are more negative than the 1933 stereotypes about African Americans. Now, by contrast, the overt stereotypes are much more positive. So they are for all models more positive than the covert stereotypes. And except for GPT-2, they are actually positive on average. So overall a positive stereotype. Now, we also looked at the temporal agreement between the covert stereotypes and the stereotypes reported by humans. And so how we did this, we in a way computed the average precision of the overall distribution of the probabilities over the adjectives. And then we compared this with these top 5 adjectives that are reported for humans, because for many of the older studies, I mean, you don't get the full distribution over all adjectives, but actually only like in the 1933 study, they only reported the top 5 adjectives. And we did this both for the covert setting and the overt setting. And I mean, what you can see here is that first looking at the light blue line, for the covert stereotypes, the agreement is the highest with the human stereotypes from 1933. And then it actually goes down for each subsequent study. For the overt stereotypes, the pattern is exactly the opposite. So for the overt stereotypes, the agreement is the biggest for the most recent stereotypes from 2012. And it's the lowest for the human stereotypes from 1933. So again, we see this, very, to us at least, surprising mismatch between the covert and the overt stereotypes that these language models exhibit. Now, there is the question, okay, is this really about dialect, or maybe there's some, other characteristic of these texts that can explain the difference that we observe here? And so to analyze this, we conducted a study where we specifically looked at individuals' features of African American English. We looked at the features that you can see here written on the y-axis of the plot. And how we did this is we actually created minimal pairs. So for example, B, which is the one feature that evoked the strongest stereotypes here, that's the use of invariant B for habitual aspect, as in he be drinking. And what we did here is, so we did our matched guys probing methodology, but instead of feeding into the model entire texts, we just fed into the model a minimal pair, such as he be drinking versus he is drinking. And we did the same for thinner, which is a marker of the immediate future, like copula is copula, absence, ain't is the use of ain't for negation instead of doesn't, for example. In here is the use of like word final in instead of ing, as in the example he be drinking. And a stay is use of stay for habitual actions, and inflection is inflection absence. So we looked at these features, and we created minimal pairs for all of these features. So it was very controlled in a way. There was no punctuation difference, for example. It was very controlled, and we found that each of these features individually evoked those stereotypes about African Americans, or like speakers of African American English, that we had previously observed by looking at these natural texts from social media. Now, maybe you're still not convinced that this is really due to dialect, maybe to African American English, I should say. Maybe it is a bias that these language models have against dialects in general. So this is a fair possibility. And so to test this, we use the value data set, which is a data set created by D.E. Yang's lab at Stanford, where they have texts in not only in African American English and standardized American English, but actually also in other dialects. And we repeated our experiment for those dialects. We took Appalachian English and Indian English as examples, and we specifically looked at like how strongly do these dialects evoke the 1933 human stereotypes, for which we found the biggest agreement in terms of the language models. And I should say, for example, Appalachian English is also evoking stereotypes, but we were specifically interested to what extent do these dialects evoke the specific racial stereotype about African Americans. And so what we found here is, here in the plot, you can see the match, or like the strength of the 1933 stereotypes. And you can see, this is again a different data set. For African American English, very strong, a very high strength, and substantially weaker for Appalachian English and for Indian English. Now, these stereotypes are still evoked to a certain extent by Appalachian English. And I should note that there is a lot of work on actually dialect prejudice against speakers of Appalachian English. And there is some overlap in the stereotypes about speakers of Appalachian English and African American English. For example, the stereotype of them being lazy. That is very pronounced for speakers of Appalachian English as well. And so this is why it is no wonder that these 1933 human stereotypes, where lazy is very prominent, are also to a certain extent evoked by Appalachian English. But as you can see, substantially weaker than for African American English. Now, there's still the possibility, maybe, okay, we see it is quite specific to African American English, but maybe it could also be a general bias against deviations from standardized American English, irrespective of how these deviations look like, right? Maybe the model is just regarding African American English as some sort of, incorrect English, or some sort of English with a lot of noise, because it hasn't seen it a lot of training data or something like that. So to test this, we took the Grunwald data that we had used for our main analysis, and we artificially injected random noise into the data by randomly inserting, deleting, and substituting both characters and words. And then we were wondering, okay, to what extent does this noisy standardized American English evoke the specific stereotypes about African Americans reported in 1933? And so what we found here is, so first of all, on the left-hand side, you can see that the strength of the stereotypes is a lot weaker, very similar to the other dialects. But what is also interesting is we also measured the perplexity of these texts for the language models. P here is perplexity, PP is the pseudo-perplexity for the models like Roberta, where we couldn't really compute the perplexity. And you can see that the perplexity is a lot higher for the noisy data, meaning the models are much less familiar with the noisy text. They have, you could also, it's always like, do models understand anything? That's a question, but you could say the models have much more, it's much more challenging for them to process this text, but they still have a much lower racial bias against this kind of text. So our conclusion out of this first part is that language models indeed exhibit covert raciolinguistic stereotypes about African Americans and speakers of African American English, and these stereotypes are specifically triggered by features of the dialect. Are there any questions about this first about this preliminary result?
Do you have like any idea why you think like the perplexity went up with the random noise?
Yeah, I think it's just way more difficult for the model to process this text. I think it's not used, given that this was random noise. I think this is very unfamiliar to the model. It has probably never seen also the kinds of words that we have with like the random character substitutions and so on. So I think it's just very difficult for the model to make exact predictions in terms of what is coming next or what is to be inserted in a certain slot. And I think the model has seen African American English in the data, of course, probably less than standardized American English. So the perplexity is still higher typically for African American English text. I mean, I think we measured this as well. I'm not showing it here, but this is also, many language model technical reports in the appendix somewhere. They look at performance on African American English, and typically you see that the perplexity is higher than for standard American English. So yeah, I should say like higher perplexity, of course, always means it's more difficult for the model to process. It's less familiar with this kind of data.
Hi, I have a question.
Yeah.
So I'll admit my background is as a theoretical linguist, and I'm of course attempted to call it African American Vernacular English. And many folks who speak African American Vernacular English, especially if they have some reasonable educational attainment, are at least somewhat diglossic, right? Or they speak both, and I think many of them are more likely to write in something closer to standard English than African American. And some of the examples you gave, frankly, remind me a little bit of something like, Huckleberry Finn or something like that, where it's dialogue, and you have, I assume you're familiar with the phrase I dialect, that they spell things differently, even though people of various backgrounds actually pronounce it the same way. So for like drinking versus drinking, the NG, most native speakers of at least American English, regardless of the background in more casual settings, don't do the NG. It just doesn't happen. And so when you do the drinking in that context, it's explicitly more casual, but also you're kind of deciding to single out something that is really not a distinctive attribute of that variety of English. So, I'm not familiar with studies of this in which people bring these features, grammatical features, shall we say, of English into the written expression, and I assume you would expect code switching there as well. That some individual, when did they try to, when did they use it, and when do they use? I assume the good majority of folks would do something closer to standard English in the written form in many contexts. So is there a little worry that this use in written form has its own kind of particular context, and that's part of what the models are picking up on?
Yeah, I think that's a great question. I think there are 2 points to this. So for one, it is true that a certain limitation is that we did not look at speech-based models. We would assume that this kind of prejudice that we observed would be even stronger because many of the phonological and phonetic features are simply not reflected in written form. Now, I should say there's a lot of work in sociolinguistics that, for example, by Jacob Eisenstein, that social media data to a relatively good extent, and this kind of writing orthographically reflecting phonological variation, relatively well reflect, or to a certain extent reflects how people also speak. So maybe there's some sort of conversational aspect to this, but I still think that the systematicity of our results across settings, across data sets, very specific, as I said, to this racial stereotypes about African Americans. I think this cannot really easily be explained just by certain, the fact that even African Americans would only write in that way in certain situational contexts. I'm happy to follow up on that later if that's okay.
Okay, thank you.
Looks like you're muted, Valentin.
Oh, sorry. Okay. Oh, sorry. You did hear. What was the last thing you heard?
Just you finishing up answering the question.
Okay. I said I should go on because we only have like 15 minutes left. So let me go on and go to the second question, which was in what ways do these raciolinguistic stereotypes affect the decisions that language models would make about speakers of African American English? So now we are going from, representational harms. Speakers of African American English are represented in a certain way to allocational harms. And we looked at two areas here specifically, employability. So what occupations would language models assign to people based on how they speak? So an example prompt here would be a person who says text is a, and then we looked at the probabilities that language models would assign to different occupations. We had a list of 84 different occupations. And then we also looked at criminality, where we looked at what are the judicial decisions that language models would make about people. And we did two experiments here. One, the conviction experiment, where we looked at whether a language model would acquit or convict a defendant. So the example prompt here would be, he's accused of committing a crime. He says text, he should be, and then either acquitted or convicted. And then we also looked at death penalty. So we prompted the model with things such as he committed first-degree murder, he says, and then he should be sentenced to, and then we looked at the probability of life versus death. And so we took some calibrated approach here. We measured the probability of these decisions in a neutral prompt, and then we looked how do they change when you insert African American English or standardized American English. And then we counted, we counted the decisions for both the standardized and the African American English setting. Now, I really should highlight here that using any AI technology and language models in particular in such settings is inherently very, very problematic. And I mean, we do not want to support it or like push using these models in these settings in any way. We're just curious to see if you were to use them in these settings, what would be the effect of dialect, given that, I mean, legal NLP is a very active area. People are training models in various legal settings. And also we know that in employability settings, AI is also used, and people, some people try to also develop language model technology or language technology that works in these settings. So I think it's, maybe we justified settings, but yeah, as I said, we really don't want people to use these models in that way. Now, we found for the employability analysis that occupations that exhibit a low association with African American English consistently require a university degree. So here on the plot, these are the bottom 5 occupations. These have the lowest association with African American English, or put differently, the highest association with standardized American English. And you can see these are things like economist, psychologist, astronaut, psychiatrist, journalist. So typically, occupations that require some sort of higher education, whereas the occupations that have the highest association with African American English are things like singer, athlete, musician, guard, cook. So typically, so you do see this association with music and art, which is interesting because this is a reported like quote unquote positive stereotype about African Americans, but in general you see they are less academic than the occupations for standardized American English. Now we wanted to capture this in a more quantitative way also, so we looked at the occupational prestige for these occupations, which we took from the USGSS, and then we plotted the occupational prestige, which is on a scale between 1 and 9, versus the association with African American English. And you can see that the stronger the association with African American English, the lower on average the occupational prestige of an occupation. Another thing that is interesting to observe here is that for most of the jobs, the association is actually, so this association score is negative, meaning that like speaking or having a text in African American English in the eye of the language model makes most jobs less likely. with another, I think, yeah, interesting finding here. Now, for the criminality analysis, as I said, we just looked at the rate of the judicial decisions for for standardized American English and African American English, and here we just show the increase in the relative increase of that rate for African American English. So anything which is above 0 here is bad, meaning that African American English in the prompt makes this more likely. And so you can see that for all across the board for all language models, having African American English makes it more likely that a language model would predict these detrimental judicial decisions. Which, I mean, if you look at the death penalty for even for GPT-4, I mean, it's an average increase of 100%, which is yeah, quite pronounced. So, like we conclude here in the second section, the dialect prejudice in language models does indeed perpetuate discrimination against African Americans in areas where we know that such discrimination also exists in the real world. Are there any questions about this?
I have a quick question. So you said
Yeah.
that using African American English makes most jobs less
It's a
likely. Do you have a
nature
sense of what
paper.
became more likely?
Pardon?
Um,
Which jobs became more likely?
or just like what in general, like yeah. So here you said that like most jobs became less likely. Yeah, just I just was curious what went up, what probability went up.
I mean, these are the jobs here outside of the orange rectangle,
Mhm.
which these would be jobs which across models, across prompts. I mean, yeah, we had all these, we had different prompts, different models, all these different input texts across all of these would on average go up in probability. So you would have things like cook, guard, soldier, priest, clergy, musician, detective, artist, operator, attendant, and collector. These are the jobs that go up, and it's, I mean, it's really interesting because, for example, priest. I mean, this shows up in the Princeton trilogy, this stereotype that African Americans are religious. It's very interesting that this shows up here. And then you have things, yeah, like artist, musician, which have this music and arts stereotype. So even the things that go up to a certain extent, I would say, like perpetuate stereotypes. But yeah, I mean, there's some argument: are positive stereotypes really positive? But some of this would show up here. Also, like I think athlete for some of the models. Where's athlete here? Athlete also, I can't find it here on the athlete also for, yeah, okay, I see it. For GPT 3.5, athlete also shows up, which is again interesting because there is again the stereotype of African Americans being athletic.
I see. That answers it. Thank you.
Okay, thanks. All right, then let's take a look at the third part. This is still from the same paper. That how can raciolinguistic stereotypes in language models be resolved? So are there any ways to actually mitigate both these representational harms, but then also the allocational harms that we observed? Now we explored two strategies that had been proposed in prior work. Strategy one is model scaling. So people have claimed that by just making the models bigger, the biases also, like biases in models also get weaker to a certain extent. Second strategy is to use human feedback training. So something like RLHF, and then align the models with human values. Now, for the scaling analysis, we first looked at the perplexity. So how good are these models at processing African American English? And we found that the bigger the model, the better at processing African American English, which had been also observed in prior work. So that's nothing really new. We also found that indeed, for the overt prejudice, so where we explicitly mention race to the model, the stereotypes also get weaker. However, for the covert stereotypes, they actually get stronger as the model size grows, right? So we again see this very interesting gap between what happens for the overt and the covert stereotypes. Now, for the human feedback analysis, what we did is we compared GPT-3 without not trained using human feedback with GPT 3.5 trained with human feedback. And we found that for the overt stereotypes, which are the dark blue lines you can see at the moment, For those, the human feedback training made the stereotypes weaker, which you can see on the left, and also more favorable. We also measured the average favorability of the stereotypes, so weaker and more favorable. For the covert stereotypes, there was no clear effect. So the stereotype strength actually got a little bit, but not statistically significant, stronger, and also no significant effect for favorability. So it seems like at least the human feedback, which was done for GPT-3, mitigates the overt, but not the covert stereotypes. And so this is also like our conclusion based on this third part, that the methods that are in place at the moment do not resolve dialect prejudice. I mean, that's not to say that you couldn't come up with a way of doing RLHF that would also propagate to these covert stereotypes. But what we have observed for all the models, what is done at the moment, at least, doesn't do anything. Now we have only 8 minutes left. If there's a lot of questions, I can also skip the fourth part and directly go to questions, or otherwise I can talk quickly about any potential effects for downstream performance. I'm not sure whether there are any preferences or how many questions there are at this point.
Why don't we try to take 1 or 2 questions and then try to squeeze in that last part?
Sounds good. Yeah.
Okay. Feel free to unmute or ask in chat if anyone has a question, or we can just move on.
The one question is about downstream tasks in the chat.
Oh yeah. Can I? Yeah. Exactly. We can't anticipate all the downstream applications. I think this sounds like a comment. I mean, I would interpret this as a comment why it is important to look at this. Because I mean, you don't really know what these models are going to be used for in 5 years. So it's really that's how I interpret this. So it's really important to already know this is a potential risk that could come up and hence could inform in what scenarios we use these models. Oh yeah, okay, yeah, and LLMs are already being used on social media data to make claims about populations. Yeah, exactly. So I fully agree with that.
But I like when you said you'd added noise to the things. What about systematic noise? I wonder, for example, young people these days, they don't like capitalization. They think that adding periods, carries some sort of meaning. So they, but I know you realize you didn't use it kind of in the social data that is widely available. But if you did, do you think LLMs would also kind of discriminate or hold prejudice against this novel variants of language?
Yes, I mean, I would think so. Yes, I think. I mean, as you can see, I mean, this entire paper was really focusing on this racial bias and all these comparisons that we did. In a way, you could say, I mean, this doesn't really matter. I mean, if you are a speaker of African American English and you speak and you write like that on social media, and then your data is used for certain analyses, and this is the outcome, you probably, I mean, you probably wouldn't care whether another dialect maybe gets the exact same thing. But we wanted to show that this is really this match, between these historical stereotypes and what the language model is doing, that there is really this significant match. Now, for what you mentioned about how people write on younger people write on social media, yes, I would assume that by the way how the model is trained, it probably would not have, again, this almost perfect match with these archaic racial stereotypes. But I would assume that the model would, for example, think that or predict that such a person is less educated, maybe sloppy. So it would be a very interesting study, to come up with a hypothesis. What would be what stereotypes do humans have about people who write in that way, and then do language models have a similar stereotype? I could easily see this happen. Yes.
And another question, kind of, I didn't quite catch kind of why you chose archaic stereotypes as kind of the object of study. Like, why not like Jim Crow laws or current modern contemporary stereotypes?
I mean, we looked in the main analysis, we looked at more modern stereotypes, like from 2012, but then later to make this comparison with the other dialect and also the noisy data, given that in the covert setting, all language models had the strongest agreement with the archaic stereotypes, we felt that this is the best you know, this is in a way the African American, the most pronounced, like the best description of the stereotypes that the language models had about speakers of African American English. And so we felt this is the best point of comparison with all the other varieties, if that makes sense, right? Because I mean, imagine we had compared with the 2012 stereotypes. It could be the case that maybe, you know, Appalachian English evokes those stereotypes to a greater extent than African American English. But I mean, the language models have they also don't, I mean, we know the language models have a much bigger agreement with the 1933 stereotypes. So for this like comparison, I think it made sense. Of course, I mean, you can see that even for even the more modern stereotypes are endorsed to a certain extent, but substantially less than
But the data that was used to train language models, you know, the vast bulk of the data is post 1933.
Yes, yeah.
So that's why I'm trying to wrap my mind about relationship between archaic stereotypes and expressions of them in the text in current.
Yeah. I mean, I think I think even though those are the stereotypes from like the 1933 stereotypes, you can see them here: lazy, ignorant, musical, religious, stupid. I mean, these are the top stereotypes that were reported in the study. I think you can still find those stereotypes on the web about African Americans, and I think if you go on Reddit, you will find exactly this kind of stereotype about African Americans in very unhinged ways. Because only because in 2012 maybe this wasn't really reported by the participants in the study. I think this stereotype is still very much alive and you will find it on social media. And so I think what our study shows is that in a way it is also reflected in social media in overt forms, but the way how we post-train these models and maybe with data filtering and so on, this is helping for the overt stereotypes, but it's not for the covert stereotypes.
There's a question in the chat.
Oh yeah.
Yeah, I'll read that out. So from Joseph, he says, I'm curious why you think that covert racism gets worse for larger LLMs. My first theory was that RLHF was somehow causing that, but your chart on GPT-3 versus GPT-3.5 with and without RLHF seems to disprove that.
Yeah, I mean, we don't have a good explanation for why it gets stronger with size. Like one thing to notice is, I mean, we know that bigger models are better at reproducing statistical patterns that they find in the data. And I mean, I think that this kind of covert racism, it's still very subtle. It's not as strongly, that would be a hypothesis, not as strongly present in the pre-training data as for the overt racism. So you could say that the bigger the model is, the better it also is at learning this kind of covert racism. Now, it's also interesting, I should say, for all the models, we looked at different sizes. This is something, I mean, if you are interested in this, you can take a look at the paper. But the only model that did not really show any strong covert racism was T5 small, which is by far the smallest model. And again, I mean, we didn't study this systematically, but our impression was that this is something it's something you need to learn, and it's not easy to learn. So you need a certain capacity to learn it, and hence size would help. Now for there was a second part on GPT-3. Yeah. Like for this, yeah, I think we don't know exactly how big these models are, but we proceeded on the assumption that they are basically the same except for human feedback, which is, yeah, probably things are probably more complicated than that. There's one question about framing, resolving bias. Yeah, I think given that, Becca, can you maybe explain this? What do you mean here exactly?
Yeah, well, I'm curious about, so you have one of the research questions being like, how can we resolve bias, which I feel like kind of comes with that assumption that bias is something that can be resolved, right? And then that was coupled with the finding of like, here's what we can do to kind of mitigate it. So I'm curious about
Oh yeah.
Yeah, about like that, how you came to that particular framing.
Yeah, maybe mitigation would have been a better word to begin with. Yeah.
Okay.
Now,
Great.
okay, I think we. Oh, fine.
Oh no, I was just gonna wrap up.
Yeah. So we have. I just for one thing. I mean, we have an interesting preprint where we show that this might also affect the reasoning. This might lead to implicit model sandbagging, where the model is performing worse on African American English text in reasoning tasks because it assumes that the user is less educated. But yeah, just wanted to mention that. And otherwise, yeah, thank you for your attention.
Awesome. This is a fantastic presentation. I'll leave a moment to do a virtual round of applause for Valentin. Yeah, thank you so much for your time. This was fantastic. Really great presentation, and yeah, thank you for coming,
Yeah,
answering all
thank
these
you so much
questions.
for having me. If there are any questions, yeah, please reach out. I'm very happy to chat or answer questions via email. Thank you.
Great, awesome.
Thank
Thanks,
you.
everyone.